Hello students, welcome to another session of online class. So today we will be discussing about how to calculate the total charge from the given volume charge density. So revising what we have learned in the last class, we have studied that the volume charge density rho v is given by rho v is equal to delta q by delta v, that is charge per a given small infinitesimally small volume. That is why limit delta v tends to 0, or it is dq by dv, and from this one the total charge q is equal to integral rho v dv, and this is integral is volume integral. So discussing about this one, we have seen that the dv in different coordinate systems are different. That is, in Cartesian it is dx, dy, dz. So in cylindrical coordinate system it is rho, d rho, d phi, dz, and in spherical coordinate system it is r square sin theta, dr, d phi, dr, d theta, d phi, dr, d phi, d theta, anything is okay. So these are the three dv values for different coordinate systems. So in today's class we will be discussing how to solve the problems related to solving the problems related to finding the total volume, total charge from the given charge density. Okay, so we will first discuss first problem. Find the total charge. Find the total charge. Total charge contained in a 2 centimeter length of electron beam as shown in figure. The figure is represented like this. This is the x-axis, y-axis, and z-axis, and there is an electron beam which is in cylindrical space. Okay, cylindrical shape, and this radius of this one is nothing but rho is equal to 1 centimeter, and it starts at z is equal to 2, and the top part is z is equal to 4 centimeters. These are centimeters are the unit, and rho v, the charge density of this one is given by rho v is equal to minus 5 e raised to minus 10 to the power 5 rho z. So what is the unit of this one? It is microcoulombs per meter cube, because volume charge density is total charge divided by small volume, right? So all these parameters are given. So from the figure we can understand that rho starts from 0 and the maximum value it can take is 1. So the limits for rho is obtained, and for phi it is the entire cylinder. So from x-axis it starts and completes one rotation. So I can say 0 to pi, 2 pi, and the third parameter is z. So z starts from 2 centimeter and maximum up to 4 centimeter. So these are the limits, this is the function. So we know that q is equal to volume integral rho v dv, which is nothing but triple integral over rho phi and z. Rho v is nothing but, why triple integral here? Because it is a volume integral, and dv is nothing but rho d rho d phi dz. So there are three parameters, depends on d rho, depends on d phi dz. So all these are the parameters, that is why rho d rho phi z are the triple integral, and the function comes here. So what is the function? Minus 5 e to the power minus 10 to the power 5 rho z, rho d phi dz. So what are the limits for z, phi and rho? As we discussed earlier, it will, z starts from 0.02 to z is equal to 0.04. Now why it is not 2 and 4? Because the unit there given was centimeters, but this unit is microcoulomb per meter cube. So we want everything in meter. This is SI unit. So I have to convert the centimeter in the previous one, that is 0 to 2 to 4 is actually 0.02 meter less than z less than 0.04 meter. Similarly here this is also in centimeters, so I have to substitute 0.01 meters. So substituting that value, that is 0.02, and phi is angle, so there is no conversion, so it is 0 to 2 pi maximum complete angle, and rho is 0 to 0.01 minus 5 rho e to the power, not rho, e to the power minus 10 raised to 5 rho z, rho d phi dz. Now the important thing is you can integrate with respect to any parameter at any time. So while considering, so this is z, this is phi equal to, this is rho equal to. So you can integrate with any parameter. So here which doesn't depend on any function is phi, so we can integrate with respect to phi first. So remaining things are z is equal to 0.022, z is equal to 0.04, and here rho equal to 0 to rho equal to 0.01, and integral, the remaining is all those functions, that is this is a function of z and rho d dz, everything doesn't depend on, they all doesn't depend on phi, so I can take all of them as a constant and take it outside rho z, and only thing is integral d phi will be left. So integral d phi is nothing but phi with the limits 0 to 2 pi. So rho d dz are constants. So upper limit is 2 pi, lower limit is 0. So 2 pi minus 0, 2 pi multiplied, you will get as follows: 0.02 to 0.04, 0 to 0.1 minus 10 pi e to the power minus 10 to the power 5 rho z, rho d dz. Again we can choose any one of the parameter. Now I will be selecting z parameter as the second integral. So dz along with all the functions which depends on z, and this is the limit. So better I can write here. So what you have now is q is equal to minus the integral left is rho, so 0 to 0.01, 0.01 minus 10 pi e to the power minus 10 to the power 5 rho z. So e to the power, so it is like e raised to ax, integral e raised to ax, where a is this total. Why I am not considering rho? Because when I integrating with respect to z, rho is a constant. So integral e raised to ax is e raised to ax by a. So using that parameter here, it should be e raised to 10 to the power 5 rho z divided by minus 10 to the power 5 rho, with limits for z is 0.02 to 0.04, and whatever left is rho d rho. So here is this one. If I substitute and calculate the value again, 0 to 0.01 minus 10 pi, apply the upper limit, it will become e to the power, there is a minus sign is there, so minus minus it becomes plus. So e to the power, if I applied 0.04 into 10 to the power 5, it becomes e to the power minus 4000 rho, minus, if I apply lower limit, it becomes 0.02 into minus 10, so e raised to minus 2000 rho divided by 10 to the power minus 10 to the power 5, so it is plus 10 to the power 5 rho is there into rho dz. So this rho gets cancels, so this we have. So in the question, you see here, okay, this if I bring here, it becomes 0 to 0.01. So 10 divided by 10 raised to 5 is 10 raised to minus 4 pi. Rho gets cancelled, so here it is d rho. So e to the power minus 4000 rho minus e to the power minus 2000 rho d rho, with the limits 0 to 0.1. So all the constants I can take outside. So what is left here is 10 raised to minus 4 pi is taken outside. So e to the power minus 4000 rho divided by minus 4000 is the integral of this one, with minus e to the power e raised to minus 2000 rho divided by minus 2000 will be the integral of this one. So I have to apply the limits 0 to 0.1. So if I apply those values here, so upper limit will be e to the power minus 40 10 raised to minus 4 pi. So if I apply here 0.01, it will become e to the power minus 40 divided by minus 4000 minus lower limit, if I apply, is 0. So plus it becomes 1 by 4000 minus e to the power minus 20 divided by minus 2000 plus e to the power 0, that is 1 divided by minus 2000. So minus minus it becomes plus again, 1 by 2000. So e raised to minus 40 divided by 4000 minus e raised to so simplify this value and you will get the final answer. So this is your homework for you to find the final value. So this is one of the question. We'll discuss one more question today. So we have to find the total charge enclosed by calculate the total charge within the universe where the universe rho v is given by rho v is equal to e to the power minus 2r by r square. So how we consider universe as? Universe is considered as a sphere with radius is equal to infinity. We don't know what is the end of the universe, so we assume that the universe is a very big sphere with the radius equal to infinity. Okay, so we should know the limits now. So which is the coordinate system we are using? Spherical. So the parameters are r, theta and phi. So r, it is the entire r, so it starts from 0 to infinity. Theta, the complete theta, that is starting from 0 to pi, and phi is the complete phi, that is starting from 0 to 2 pi. So we know the limits for all the variables. Now we have to integrate and find. So the function rho v is equal to e raised to minus 2r divided by r square. So as we discussed in the previous problem, rho q is equal to volume integral of rho v dv. But here the coordinate system is spherical, so volume integral is triple integral over r, theta and phi with rho v as e raised to minus 2r by r square into dv is r square sin theta dr d theta d phi. So here if you see r square gets cancelled. Now the remaining parameters are e raised to minus 2r and sin theta. So for there is a function for r, there is a function for theta, but there is no function for phi. So we will finish that one. So the limit is 0 to infinity, 0 to pi, 0 to 2 pi, e raised to minus 2r sin theta dr d theta d phi. So we will finish this part. Okay, so that is nothing but we have now 0 to infinity, 0 to pi and e raised to minus 2r sin theta dr d theta are constants, so I can take it outside, into what is the integral of d phi? It is phi with the limits 0 to 2 pi. So which is 2 pi, which is a constant, I can take it outside. So 2 pi into remaining 0 to infinity, 0 to pi, e raised to minus 2r sin theta dr d theta. Now again if I consider integrating. uh, Here I can consider theta as the parameter. Now 2 pi is taken outside, q is equal to 2 pi is taken outside, so 0 to infinity e raised to minus 2r. So integral sine theta is minus cos theta with the limits 0 to pi. Okay. uh, then left over is dr. So what is minus cos theta 0 to pi? So that will be 2 pi into cos minus cos pi is minus of minus 1, that will be plus 1, minus cos 0 is, so it will be like I will write here for simplicity e raised to minus 2r 0 to infinity. Cos pi is minus 1 minus cos 0 is 1, so again minus 1 dr. So minus 1 plus 1 plus 1, so it becomes 4 pi. So it is 4 pi 0 to infinity e raised to minus 2r dr. Again the left integral is e raised to minus 2r, which will be e raised to minus 2r divided by minus 2 with the limits 0 to infinity. If you substitute r equal to infinity, upper limit e raised to minus infinity, it will become, we know that e raised to minus infinity is 0. So this is a very important parameter we have to always consider. So the left things are e raised to, that will be 0, minus divided by minus, it will be 0, minus e raised to minus 2 into r is 0 means 1, e raised to 0 will be 1, so 1 divided by minus 2, so this will become plus 2 divided, so 2 times, so that will be 2 pi or 6.28 coulombs. Okay, so this is how you have to calculate the total charge if the charge volume charge density is given. So that's all for today's class. We'll discuss more problems in the upcoming classes. Thank you.